Hello, Chris.
Hello, Daniel.
It's a pleasure to have you in here today.
It's a pleasure to be here.
I've been looking forward to doing this podcast for a long time.
I've been dreading it.
We got a lot of stuff to cover today. I've had Ben in here, Ben Kirkwick from Uncharted X a couple times now. And he's talked a lot about some of the stuff that you've been working on for the past few decades. He and I are both huge fans of your work. He obviously, cites all of your work when he does his stuff and when he goes to the pyramids and reports some of the stuff in his videos on Uncharted X. And that's how I actually first discovered you, was from when Ben came on here about a year ago. After he came in, I read your book, The Giza Power Plant, twice. Just finished reading your new book, The Tesla Connection, which was mind-bending to say the least. Maybe you could give us sort of a brief background on your history and how you got interested in the pyramids of ancient Egypt.
I was raised in a working class family in Manchester, England. And my father was a butcher and my mother was a housewife. And I have 4 siblings, a brother and 3 sisters. So it was a very loving household, and I ultimately decided at the age 15 that I was done with school, and I pled out to take an apprenticeship, and was hired by a company called Mather and Platts. They were an engineering company in Manchester. And so at the age of 15, I entered their apprenticeship program, worked there as an apprentice for 6 years. I started out, as I recall, my paycheck was like $7 a week for 40 hours.
Oh, wow.
Right. So apprentices were not paid much back then. I mean, if you go back to, the really old days, like Victorian times, apprentices, parents, fathers would take their sons to apprentice with a tradesman, a craftsman, and they would pay them to take them and teach them a trade, or they would work for nothing, but they would kind of stay with the tradesman, a craftsman, and serve their apprenticeship away from home.
Right.
So anyway, this was kind of like an indentured apprentice. I have my documents, indentures that I was given when I completed my apprenticeship, and then I left the company as a journeyman, specializing in lathes. So,
in lathes?
Lathes.
What is a lathe?
Lathe turning.
What is that?
It's a machine tool that is used for machining parts, round parts particularly. Very precise round parts. There are all kinds of lathes. There are vertical lathes, horizontal lathes, and they've developed over the years. There capstan lathes, turret lathes, tool room lathes. Every one of them has different features. So so that was my specialty at the time, and I took that with me and went to work elsewhere when I was 22. Worked at a forge for a bit, and then I went to work at a company called Hunter Musgrave, and they made paper milling machinery, textile milling machinery, really, really long shafts and rollers and stuff like that for industry. While I was there, I saw an ad in the Manchester Evening News, and it was an aerospace company in the States that were recruiting machinists to work in the aerospace industry.
Okay.
Right. So
What year was this?
That would have been around 1968.
Okay.
So in 1968, I applied for the position, and I got a telegram saying that I'd been selected, and I had to get a visa to come to the States and start working.
Oh,
so
wow.
I finally left the shores of my home country in 1969 and landed in New York on May the 9th, 1969.
Okay, so you came to the U.S. in around 68 to work for the aerospace company.
Yeah.
And what exactly were you doing for those guys?
Well, they hired me to run a vertical lathe they call them bullards.
Bullard.
Bullard. B-U-L-L-A-R-D.
Okay.
I mean, you got millions of machinists around the States who will recognize that word.
Okay. What does a bullard look like?
It's a vertical lathe. It's like they've got a round chuck, and then you've got the typical axes that move a turret so that you can cut inside and outside diameters.
Oh, is this a bullard? Okay,
so
that's an intense looking machine. Wow.
Yeah, before when I was in England, I ran a Webster and Bennett. So in England, they call them borers, vertical borers.
Oh, okay. And
in the States, they call it vertical lathe.
So can you explain to me what this thing is doing here?
Well, right now it's just sitting there. There's no part. But if you see that there's a chuck there.
Yeah.
Okay, so you mount a part to be machined on the chuck, and that hexagon kind of thing that has it's not a hexagon, is it? But it has a tool post, and you mount tools in the tool post and cut the parts on the outside and inside, different shapes.
What kind of materials?
Well, in aerospace, you're talking about exotic alloys like Inconel, Hastelloy X.
Okay.
Yeah.
Okay.
Heat resistant, corrosion resistant alloys. When I first came to the States, I worked for a place in Martinsville, Indiana called Twig Industries. And Twig Industries, they were a subcontractor for some of the major EOMs like General Electric, Allison Engine, which is now Rolls-Royce in Indianapolis, Pratt & Whitney, and other aerospace companies. So they did a lot of aerospace stuff, including stuff for the moon landing. So,
oh, really?
Yeah.
What kind of stuff did you guys engineer for the moon landing?
Well, they were a manufacturer. They didn't necessarily design it or engineer it. They engineered the processes.
Okay.
It was the framework for the survival pack for the astronauts when they went landed on the moon and did their moonwalk. That box of air that they had on their back, right?
That box on their back, you guys made that?
The framework for it, yeah.
And
so it was a weldment.
What is that box on the back? Like, what does it do?
It's their survival. I guess it provides, heat and cooling to their suits, keeps the temperature. Regulated and monitors their physical functions and that stuff.
Okay. Wow, that's fascinating.
They had made that before I got there. Because the moon landing was in June, right? The month after I arrived.
Oh, wow. Okay.
Yeah, it was
good timing.
It was interesting. There's a thing about manufacturers and the inside jokes and the way people talk about the company and stuff like that, right? So it's like there was one old wag said something. He said, "Well, we know that the astronauts are going to come back. They'll make it back because everything Twig makes always comes back eventually." So,
Oh,
in other
God.
words, it's kind of like everything they make has got flaws, so it's going to come back.
Oh, God. Well, at least you got a sense of humor.
Well, you got to have a sense of humor.
Right, of course. Yeah, it's valuable. So how long did you work for this company?
And I only worked there for about a year, just under a year.
Oh, okay.
In Martinsville, yeah.
Okay. And what did you do after that?
Then I went briefly to Texas, and then I worked at a very small shop in Indianapolis. I came back to Indiana and worked in a very small shop. They made drapery, machinery, and wheel balancing equipment.
Wheel balancing equipment.
Yeah. So it was 1970. So we were kind of heading into a recession at that time. And so it was very hard, very difficult to find work. So I just got the best job that I could get at the time. And then after that, I went to a place called Beulah, which was known as Indiana Gear Company. They made gears for helicopters and other aerospace kind of products. So,
okay. So what is the process when you're working for these companies that are making these gears or any of these aerospace pieces or parts? Like what is the process to actually creating them? Like you're operating this big machinery. So does people send you plans or like schematics for how this needs to be done and what materials they need to be done with? And then you guys sort of figure out how the cuts are going to be made and all of that. How does that process work?
Yeah, generally the manufacturing process that I have experienced, and every company is different, of course. But what I've experienced is that the company will receive an order from a customer that will include drawings and specifications. Some of the specifications are on the drawing, others are in a separate sheet, but they will control the process. So the engineers will then take those drawings and design a process and create their own drawings, breaking out all the various elements of the drawing. So if the drawing has multiple parts, assemblies, sub-assemblies associated with it, like a jet engine, let's scroll through here and put up. So essentially, you've got various parts to a jet engine, and they're comprised of individual single parts. Those single parts could be made of sheet metal. Mm-hmm. They could be forgings, castings, and they are basically cut, welded, machined, formed in all different kinds of configurations, and then put together. They may be brazed, welded together, which would include maybe spot welding or, TIG welding. Mm-hmm. And then those sub-assemblies are then shipped to the customer, and the customer installs them in their engine. Interesting, while we're on this drawing, we'll talk about some of the elements. One of them, the principal elements of the shapes that you find in a jet engine is a truncated cone.
Right. Okay.
So the truncated cone will appear in just about every section of the engine, from the front end to the aft end. But anyway, getting back to that process, the manufacturing engineers will submit a plan to the production. Then production will review the plan. The engineer will have tools, dies, fixtures, gauges ordered from suppliers or to be made internally. Mm-hmm. And then everything will come together with that particular part that they're designed to produce and inspect.
Okay.
So accuracy The complexity of these parts is very, very. They are unique because you have the application of geometries such as a airfoil shape or something like that. That's applied to a truncated cone or other parts, and then they're supposed to fit with precision. You cannot allow for any variation of accuracy, no variation whatsoever.
Right.
You have certain tolerances that you work within, right? Maybe 1, 2 thousandths, sometimes maybe 20 thousandths, but you have to stay within those tolerances. Otherwise, the part is no good.
Wow.
It could be either scrapped or you may have to rework it, which just adds cost and reduces your profits, right?
Wow.
The point is that when it comes to public safety, you have to follow due diligence,
Right.
and that is with the people you hire, from engineers down to tool makers, to machinists, to production employees. All of them are obligated to adhere to very tight standards.
This is an example of probably something that requires the utmost precision than probably anything on earth, because you're building engines that are on planes that are carrying hundreds of people. Right. So I assume, like, even building skyscrapers, you don't have to be as precise as you have to be when creating something like this, which contains, I'm sure, millions of very tiny parts in different types of materials that fit together that create the entire thing.
They say when they ship a jet engine, say like a large Trent engine, Rolls-Royce maybe, shipped to a customer, the paperwork that goes with it, all the certifications, weighs more than the engine.
Wow. That's incredible.
Yeah, so it's a.
And your son works for Rolls-Royce, by the way. That's a little interesting aside. Your son is working at the aerospace division of Rolls-Royce.
Yes, yeah,
that's amazing.
Working in metrology there. The reason I want to share this with you is because it does have an impact on the way somebody who is from this industry, or even any kind of manufacturing industry, the way they look at ancient Egyptian artifacts and how they interpret what they see, and I think it also is what has created a bit of a schism, between manufacturers and technophiles, those who are really into, they have some technical education, even though it's not identical to, say, another field. You will have certain experience in technology. Maybe it's media or photography or electronics or things like that. And so your brain is wired a certain way. But you don't have the shop experience of actually going down into the shop and creating these artifacts,
right?
And knowing what can change something to make it not workable, and there can be very slight changes that will, say, the geometry on a cone. It doesn't have to change very much for it to be scrapped.
Right.
So if you misinterpret a drawing, or something like that, and cut something out of print, then you scrapped it.
At what point did you become aware of some of the artifacts and the pyramids and everything in ancient Egypt?
That was in 1977.
Okay.
Yeah, and I was working as a tool and die maker, in Indianapolis, And I was I was in a bookstore, and I saw this book by Peter Tompkins, and that's me there. Oh, wait a minute.
Oh, wow.
Yeah.
Okay, yeah, we didn't talk about this.
Oh, you want to talk about
Yeah,
it?
let's talk about it. What is this?
I don't know. If I tell you about that, I may have to kill you.
It'll be worth it.
No, it won't. It's no big deal. But yeah, there's a story behind it.
Wait, you really can't tell the story?
Well, yeah, I guess I could.
So what is this plane, and where is this?
That is a F-117, and that is the stealth fighter.
Yes.
First
Oh, yeah.
appeared in the Desert Storm.
And which part of this plane did you build?
Well, I am not going to claim that I actually cut those parts that you see on that plane. But there was a period of time I was running a laser job shop in Indianapolis.
A laser job shop.
Yeah,
Okay.
yeah.
What does that mean in English?
Well, we were using high-powered lasers to cut aircraft materials,
Okay.
right? So I was working for a company called Reddick Engineering, and Reddick was a great guy, right?
Mm-hmm.
And I was encouraging him to get into lasers because I had become fascinated with lasers, and and he actually went to an auction and bought a Perkins Elmer helium neon laser with retro reflector and a target for alignments and stuff like that. And he comes, wheels it over to my bench, and he goes, "There you go, bloke. See what you can do with that."
Wow.
Right.
What do one of those lasers costs?
Well, I don't know what he paid for it, but it wasn't much because he
Okay.
was a cheap bastard.
Yeah, I got it on an auction.
No, he was a good guy,
Yeah.
but a cheap bastard.
Some of the best guys are cheap bastards.
Aren't you, though?
Yeah.
Yeah, so anyway, but the one day a guy comes in with these panels, right? And he wanted me to set them up in the laser and cut these rectangular holes in them.
Okay.
But they were on compound angles. And it was an array of them, right, in a square.
Yeah.
So I set them up, programmed the laser, and cut those little squares. And then I go to, I see the F-117, and I'm looking at the air intake on the front. And it's like, those look remarkably like those panels
Wow.
I cut. And the engineer that brought them in, I was like, hey, what? I was always very curious about where this stuff went,
Yeah.
what it was used for, what the application was. I said, what are these for? What are these for?
Uh-huh.
And he goes, can't tell you.
It's classified.
Just cut them.
Just cut 'em.
Actually, you're not cutting, you're burning. The laser burns it, it doesn't cut it.
Wow.
Right. So anyway, that's that story.
That's amazing.
Yeah, so the secret.
So this is the first book that you came across about the pyramids in Egypt.
Yeah, that was 1970.
That cover is interesting looking. You see all the dirt that's coming up the side of the pyramids? All the sand or whatever it is?
That is, that is an artist impression of it. I don't think it's accurate, but it is true that the pyramids, they had a lot of sand and also rubble, because the pyramids were pretty much destroyed. Most of the casing stones had been shaken off in history. The official theory is that they were used to build the mosques and minarets of Cairo, and they were using the whole Giza plateau as a quarry. And there's signs of that too, that they were actually doing some quarrying out there. You see evidence of Roman quarry marks, particularly to the south of the second pyramid.
Okay.
Khafre's pyramid.
Okay.
And you'll find a lot of granite blocks. Some of them still in situ up against the pyramid. Others laying out in the field to the south, and they will have these these slots or grooves cut into them, where they try to wedge, cut them into pieces, and succeed in some cases.
Wow.
Yeah, and the interesting thing there is that
you're talking about the actual the dynastic Egyptians were doing that.
I don't think it was the dynastic Egyptians.
Okay.
I believe it was. I think it was the Romans.
Oh, the Romans. Okay.
Right, because in other parts of the world you'll see the same kind of technique that they use for quarrying.
Okay.
Right.
Okay, got it.
And then the question is, if the dynastic Egyptians built the pyramids, right, why would they proceed to tear them apart?
How'd they tear them apart?
Well, you say, well, did the dynastic Egyptians create those quarry marks? Well, they were actually stripping the granite away from the pyramid. And so it really doesn't make sense to build a pyramid and put all, go to the trouble of putting all that beautiful granite against it, and then, taking a hammer and chisel.
Like the casing stones and stuff like that.
Right.
They were stripping it away. And
Right. So I think they...
Who was the first person to come up with the idea that the dynastic Egyptians were responsible for the pyramids?
Who was the first person?
Or the first group, or where did that come from?
Well, that has been in the official literature for a long time.
Didn't you say that it was written by Europeans, that history?
Most of the Egyptian history was written by early Egyptologists, which were Europeans. So in England, William Flinders Petrie was considered to be England's or Britain's first Egyptologist. Auguste Mariette, French in France. And so, the Europeans were very active in studying Egyptian artifacts and also, taking a few home with them.
Yeah.
A lot.
Mm-hmm.
A lot of them home with them. So they, as far as the, assigning the time period for the building of the pyramids, because the pyramids were assigned to a particular king and period of time, they placed them in the fourth dynasty.
The fourth dynasty.
Fourth dynasty, right. So it's like 2400 BC, something like that.
And when did you first go to Egypt?
86.
86,
yeah.
Okay.
Right, 86. Yeah, that was, it was different in 86. It was very chaotic, and it was a bit of a culture shock for me. But the interesting thing was, I was really nervous because I'd already been writing, about my theory on the Great Pyramid, which occurred to me in 1977. And so when I actually came face to face with the pyramids, which anybody who writes about the pyramid must visit it eventually.
Yeah.
Right?
You'd think.
Sooner rather than later. Mine was much later than I had hoped. But that's the way things work.
So I didn't know. So you started writing about this before you actually visited Egypt.
I did, yeah.
What prompted you to begin writing about it? And where were you getting your information from?
Well, that's the thing. You see, I was, and that really heavily influenced my mind, because I was looking at the pyramid and the schematics of the pyramid as an engineered product that had the precision of a machine.
It's football season, baby, and you know what time it is. Time to gamble all that hard-earned money on some sports. As a bettor, you demand perfection, and that's where MyBookie delivers. NFL, college football, and a brand new cash-out system give you the options to bet and win all season long. First 2 legs of your parlay already hit. You can cash it out early and place another bet, or sweat it out and let it ride for a chance at an even bigger payday. Join the MyBookie family for an entire season filled with daily odds boosts, same-day parlays, and super contests. And this season, MyBookie has a no-strings-attached cash bonus that lets you deposit and withdraw quick. Use the promo code DJP on a deposit of $50 or more, and you can receive up to $200 cash instantly into your MyBookie account. Bet your deposit amount once, and you're ready to withdraw at any time. Again, that's promo code DJP to claim your cash deposit bonus. You can bet anything, anytime, anywhere, only with MyBookie.
It was a kind of an evolution of that thinking. Gathering all the information from Tompkins' book, which included the pyramids and temples of Giza and what was contained in there, that I became convinced that the effort for building the Great Pyramid, it did seem to me that the culture that built it was much more advanced in terms of their technical manufacturing capabilities anyway, and than what we have been taught. So that is clearly evident, and I think that has been supported by most engineers and technicians who have been over there and actually started to study them with that thought in mind.
Were you the first person to come up with the theory that the pyramid was a power plant?
Guilty. Let me back up a little bit. There was a general period of time in the 70s where there was a lot of interest in something that they called pyramid power, in that the pyramids had, just by the shape of a pyramid, it had this kind of energetic value. So there was a lot of talk about that. There was a book written by Patrick Flanagan back in the 70s. It was called Pyramid Power. There were other books written that referred to the Great Pyramid with talking about pyramid power. But it was a mystical kind of power rather than a practical.
Mystical, how so?
Something that was not quantified in physical terms, or three-dimensional terms.
Not measured.
Not measured. It's more like something that we didn't quite understand, couldn't quantify.
And was that based on like people standing in the pyramids? And
it's based on a lot of that kind of information, or those experiences. It was more an experiential kind of an experiential experience. Scratch that.
Right.
No, it was more an observation.
And subjective
in a lot of ways. Some of it was, they tried to measure it, but they were measuring effects rather than identifying what kind of energy it was.
Okay.
The sharpened razor blade experiment was very popular back then, where the pyramid was said to, if you put a razor blade inside a pyramid shape, then the blade would stay sharper longer.
What?
Yeah. So it had a lot of different values.
Is that true? Does the razor blade stay sharper longer if you keep it inside the pyramid?
I tried that, and I did it. I said, well, I'm going to try it. So I used a razor blade for a little longer than I thought. But then I had the thought in my mind was that doing those kind of experiments, those are already done. What was needed was a complete kind of reverse engineering of the structure to determine and find answers for every single part of it.
Right.
What was originally designed into it, what was introduced afterwards that was not a part of the design, what the operation of the pyramid, what effects that may have had in certain areas. And so there is quite a lot of information that I had to go through to find answers for. A lot of mystery.
Can you in your book, you do a beautiful job of explaining reverse engineering. Can you give me the rundown on how you reverse engineer something?
Well, it's very simple. It's like if somebody comes to you with say you're a manufacturer, somebody comes to you with a product that already exists. They don't have any drawings. They don't have any specifications on it at all, and they say, I want you to make this. I want you to make this exactly like this. And if you do that, then it's going to function the way I think it will. Okay, so you make it identical to the original. What do? You take the piece, you take it to the lab, you measure every single part of it, how many parts are actually in it, and then you determine a process on how you would reproduce it, right?
Okay.
And then you reproduce it. And then you compare it to the original and say, okay, does this look like the original? Is it similar to the...
Is it made the same?
Measure to measure.
Measured out perfectly.
Yeah, it's not just a matter of looking at it and saying, yeah, that's close.
Okay.
It's like, no, you got to measure it, and you got to be very exact.
Okay.
Now, the other part to reverse engineering is to try and determine what goes on inside an engine or inside a device, a machine, a complex machine, any complex machine, how it functions based on its output when you can't see what's inside, right? So first thing you've got to do is open it up, and then you try and determine through examining every single component inside it how it functions. I mean, manufacturers do that all the time.
So it's the reverse effect of engineering something, which is when you're engineering something, you say, hey, I want something that achieves this. I want something that performs this task. And that's when you're engineering. You say, okay, how do we perform this task? We put this thing together. We build the parts that we think are going to do this, and then measure everything, and then...
Measurement, design, and function. So,
measurement, design, and function. Right.
So you measure, you analyze the design, you take measurements.
And you figure out the function.
Determine what the function is.
And engineering is the opposite.
So
engineering something is function.
You have a particular function that you want a device to perform, and so then you do the design, and then you build the product with using the measurements.
Right. When you started writing about the pyramids, and you were sort of like seeing sort of diagrams in the 70s had already been done, and all of the chambers that are known about today had already been discovered, and you sort of knew what it looked like.
Yeah.
And you just assumed that, there's no way something this precise with these weird shafts and compartments and voids was built for a tomb. You thought intuitively that it looked like something that had a function.
I did, yeah. Let me see if I can bring up a cross-section of the Great Pyramid. So this is an image out of my book, and the different features on the inside is what really caught my attention.
Okay.
We'll start with the downward shaft, which is this particular shaft right here. Sorry. So this shaft right here, over the constructed portion of it, from the opening here down to the bedrock, was straight within the thickness of a thumbnail. That is 20 thousandths of an inch. Okay. The passageway, it's called the descending passage. The passageway is around 40 inches square. I think it's like, around 40 inches square. Mm-hmm. And it goes down 350 feet to this bedrock chamber. The entire length from the outside of 350 foot long is only out 1/4 of an inch, and that is also the excavated portion.
40 inches wide. I assume people haven't been down there, right?
Yeah, I've been down there.
How do you get down there?
I wouldn't get down there today, obviously, but
you go 300 feet down a 40-inch tunnel?
Yeah.
People still do this?
People do that, yeah. Yeah, I mean,
is it all lit up and stuff for people to like? Is it?
Yeah, there are lights. There are lights along there, and you get down into the subterranean chamber, and some people have even gone into this shaft right here that's cut even smaller than the 40 inches. There was a story about that. I mean, in my book. Mm-hmm. On a tour that I co-hosted in 2018, there was a geologist, an engineer, and actually 2 engineers. One, Andy Leskowitz, he went down to the end of that shaft.
How wide is that little shaft on the end of that chamber?
It's very small. I mean, I won't fit in it. You might. I wouldn't. When I was a lot younger, I would have gladly gone down there. But
so
it's late now.
This cross section of the pyramid, this was available in the 70s. Everyone knew about all of these chambers, and these shafts were all known then.
All except for I.
Right. I is the recent one, which was found by the Scan Pyramids Project.
Yes, exactly.
Okay.
Yeah. So the big void that was discovered in 2017.
Okay.
Something like that.
Okay. So you saw this, and what was the first thing that went through your head?
It was really weird. It was very mysterious because I was like, what's going on here? I'm like, there's something going on here, and I don't know. I didn't know what it was. I was like, but it's just so mysterious. And I just sat down and I started to draw these 3-dimensional drawings of the different chambers, right? And then just looking at it, it was, and trying to figure out what each of those chambers was used for became my passion. But the thing that struck me the most is the incongruity of the shafts, the small shafts. There's a story behind those that is quite exciting, really. But they're really important to the function of the machine. So yeah, all of that struck me immediately with the precision. Just the angles, the different shapes. It was all very machine-like to me. And I think, when it comes to saying that the pyramid was a machine to produce energy, then yeah, I was probably the first to actually put that out.
What type of machine do you believe that this pyramid is, and how does it work?
In my first book, it was called The Giza Power Plant, as you know. And
yes.
Okay, so the Giza Power Plant described the Great Pyramid. I described it as a coupled oscillator, in that it was connected to the Earth. Its proportions were an integer to the Earth, and it was tuned harmonically to the vibrations of the Earth. That was what I proposed. Mm-hmm. And as such, it reacted to the Earth's pulse or the Earth's hum vibrations, and through that they were able to stimulate electron flow in the central granite chamber, and produce microwave energy. So basically, I describe it as a maser, but it was
maser,
like a solid state maser.
A solid state electron harvester.
Well, that's what ultimately I called it. Yeah, it was a electron harvester. And so that was in my first book. I didn't call it electron harvester.
Oh, that was until the new book. Okay.
Yeah. Well, I realized that a lot of people will look at the word power plant, and the vision that comes to their mind is like smokestacks,
right,
long trains of coal snaking through the countryside to these power plants, and so kind of, and then of course power plant, a nuclear power plant, coal power plants,
right,
and stuff like that.
Right.
So that's generally associated with boiling water, creating steam, pushing turbines, and drawing the electrons off the generators. But this was kind of like a different concept in terms of creating energy or drawing energy from the Earth directly without burning fossil fuels or smashing atoms.
So underneath, in the cover of the Giza power plant, you have the pyramid sitting in the desert, and then underneath that you have like it looks like lava underneath, and then like the crust of the Earth. So I guess you're describing that seismic activity that's happening inside of the Earth, creating vibrations that are resonating with all the rocks in the pyramid.
Yeah, that cover was created by my publisher, Bear and Company. They're artists, and basically it does represent what you just said.
Okay.
As far as strict accuracy to engineering drawings, that you don't see that there, but it loosely gives you an idea.
Okay.
Right. It represents the pyramid, energy coming out of the pyramid, its connection to the Earth, and energy going on inside the Earth that is tapping into.
So you theorized that the pyramids were harvesting energy and generating energy to power whatever civilization created them.
Yeah.
And how do they get power from the pyramids?
How do they get it?
How do they use it?
Oh, how do they use it?
Yeah.
That is a good question. It's a question I get asked a lot. The problem that we have is when you look at the pyramids, so you go to Egypt and you walk around the pyramids and the temples, you look at the skeleton of a civilization. Obviously, there's so much that's missing, that has disappeared over time.
Right.
We don't know why. And so when you ask the question, well, what were they powering? We don't find any microwave ovens out in the desert. So, and you probably won't. The only thing that really survived from that period of time was
the rocks.
The rocks.
Yeah.
Right. So you some other materials, but the rocks basically survived. And it's a matter of then again it's like, okay, so what we're left with is the rocks. So what do? We take measurements. We look at the design. We analyze the effects of certain spaces, like the King's Chamber, the effects of that chamber, with the acoustic effects of it, the acoustic effects of the Grand Gallery. So there's a lot that we can study to try and come up with some answers as to how it functioned, what it did. And it's an evolving. I would call it like I would say that it's it's kind of like an international brainstorming session.
Right.
So I mean, if you ask me what my whole role is in this thing, I would say I'm just like I'm a mechanic that comes across an engine in the desert, and I'm trying to figure out what the engine does, right? And so in order to figure it out, I need a lot of help. I need the assistance of experts in different fields: physicists, electrical engineers, acoustic engineers, geologists, materials engineers. All of those people have input. And so that's what I did. I talked to civil engineers, I talked to electrical engineers, I talked to mechanical engineers as I was developing the theory for the book.
Okay. And when you first traveled to Egypt and went inside the pyramid, what did you discover from your experience, from your personal experience being there, going inside the chambers? Did that have any sort of effect? I'm sure it did on some of the writing you did previous to that.
Profound effect. Profound effect. I mean, just the experience of being there is just mind-blowing. Whether you're writing about it or, just a general tourist. I mean, I've seen people really affected tremendously just by, going in the Great Pyramid. But as far as how did it affect my perception or ideas or what the Great Pyramid was, I was worried. I was extremely worried that it would when I went there, and I was on my way to Egypt, and I'm thinking, "Oh, Dunn, what have you done now? You're going to Egypt, and what if it's all not as you read, and it's something totally different, and you're just going to leave thinking, okay, well, I just wasted, 6 years of my life or whatever."
Right.
So, yeah, I was concerned about that. And that actually kept me away from the Great Pyramid. I didn't go into the Great Pyramid for 3 days. It was like I was, eyeing it warily from a distance. And didn't want to go up there.
You were afraid. You were afraid that might kill your dream.
Yeah. Yeah, there was a bit of nervousness there. There was also a lot of, I don't know, just acclimatizing to the culture there was kind of difficult back in '86. It's a lot easier these days. So, but anyway, the third day I was there. Fourth day I went up and paid to go in, and went in, did a few checks, and it was like awe-inspiring, and it just the different dimension that it provides you. It's not just a clinical review of books, many different books that I accessed over the years when I was studying it. It wasn't just a clinical analysis at that point. It became a living thing. It was kind of like a totally different dimension.
It's one thing to read a story; it's another thing to live it.
Right. It's like, okay, so I'm looking at lines on paper, and now I'm inside those lines.
Right.
And then after that, I went outside and pondered on the whole thing, and started to wander around the plateau. But that's when I started to look. I started to look at a lot of the casing stones and the stones on the south of the Khafre's pyramid, the second pyramid. So I'm walking around there, and I'm looking at these, what I consider to be really, really sharp and flat, sharp angles, sharp corners, very well cut stone with flat surfaces, and then some other unusual shaped stones that looked like they were extremely precise. But this was in '86, and I didn't have any tools or instruments with me to see if indeed what I was looking at was actually precise.
Right.
And you can't really tell by looking at the photograph, just how, or looking at it with your eyes, just exactly how precise it is. You have to measure it.
Right. Okay.
Right.
Okay.
So that's what when I left, I had that in mind, that next time I go, I need to take some instruments with me and check things out a little closer.
And then how long did it take before you went back?
1995.
Oh, wow. Okay.
It was you remember in 1993, Rudolf Gantenbrink did the exploration of the southern shaft in the Queen's Chamber.
Okay. Who is Rudolf Gantenbrink?
Gantenbrink was a German robotics engineer, and he was commissioned by the German mission in Cairo to clean out the shafts because they wanted to install some ventilation in them to protect the monument. So he was contracted to go to Egypt, he designed and built a robot to explore the shafts. And particularly, it was the King's Chamber that he was focused on, was actually clearing it out and then installing fans.
Okay. Do we have any images of this?
Okay. So if we look at this one right here.
Okay.
Okay. What you see here is the southern shaft opening, which has particular significance to the theory, the microwave theory.
Okay.
This is an opening in the south wall, and it's directly opposite an opening in the north wall. It's right here. Okay?
Mm-hmm.
So this opening here has dimensions of 8.4 by 4.8 inches.
Oh, wow.
So generally the guidelines for creating a waveguide are the height is about half the width of the length. So
what is a waveguide?
A waveguide carries microwaves.
And what is that used for today commercially?
Communications, for the most part.
Like, for example, what?
Oh, just about everything that we get. I mean, you got these microwave towers. Try and pull up a microwave horn antenna on the internet.
Okay.
So you have those. They're all different shapes and sizes. And, there is obviously, I don't work in the microwave industry.
So where's the waveguide here?
So okay. That's a horn antenna with a waveguide, right? And there are some where you have curvatures on the interior surface. But you see the waveguide itself, the horn, receives a broader signal and then narrows it down to the waveguide and transmits it through a waveguide.
Okay. All right. So that's what we're looking at when we're seeing those little shafts. The dimensions of those are.
If you believe what I'm telling you.
Okay. Right. I believe it, man. I believe you.
So when I saw that, it was like, okay, that looks like a horn antenna, right? And that's in the south wall of the King's Chamber. Directly opposite is a shaft where the width is almost twice the dimension of the height. So you do have that rectangular kind of opening. It's 4.8 high and 8.4 inches.
Okay.
So essentially, the width has to be related to the wavelength of the atoms that are used to create the microwave signal.
Okay.
Okay. And the wavelength of hydrogen is 21 centimeters, or 8.309 inches. So it's almost 8.4 inches.
Close.
So if you had some kind of a liner in there, maybe gold-plated liner, then you would have
so if these things could have been plated or coated on the surface, it would be a little smaller.
It would be just a little smaller.
So it would be, it's the perfect dimensions for a waveguide for hydrogen.
It's very, very close. Well, I mean, just as it is, it's close.
Okay.
But they could be lined. Now, of course, critics will say, well, there has been nothing found in the archaeological record that would indicate that those things even ever existed, and that's maybe true, except for one plate that was found by Petrie on the south side of the Great Pyramid near the shaft, and that is an iron plate, and on one surface of this iron plate there is signs of gold, that it was gold plated at one time.
So there's two shafts going out of the king's chamber,
right,
which is in the upper middle of the pyramid,
right.
And so H and J on this diagram,
right,
these are what we were just looking at, these waveguides,
right,
allegedly, and one of them brings something in, and then it goes through the king's chamber, and then the other one shoots it out.
No, something happens in between.
Yeah, something happens in between inside that king's chamber, G.
Right.
What happens inside the king's chamber?
Okay, so inside the king's chamber, what you have is it's a resonant chamber. The fascinating features of the king's chamber are that it's constructed of granite. Red or pink granite from Aswan.
Is that unique for the other chambers in the pyramid?
This is the only chamber in the pyramid that has granite.
Okay.
So the granite was brought from Aswan, which is 500 miles away.
Okay.
From where the pyramid was.
How
built.
much granite is in that chamber?
Oh, thousands of tons.
Thousands of tons of granite.
You're talking thousands of tons. There are like 43 beams above the chamber itself. Those 43 beams weigh between 45 and 70 tons each.
Are we talking about those beams that are above the chamber?
Right. The beams are said to be relieving chambers. They're stacked in a series above. There's 5 layers, and a space between each one.
Mm-hmm. And it looks like the bottom of the beams are perfectly square on the bottom and edges, and the tops of them are very rough.
Right. And so in the Giza power plant, I proposed that those beams were intentionally made that way, and it wasn't a lack of attention, rather than it was a very specific, focused attention on the beams to make sure that they were tuned to a particular frequency when struck. So you have a situation where the sound input into that chamber, or vibration into that chamber, would resonate, would cause the granite to resonate, and the beams above would resonate also to those frequencies.
Okay.
And the other interesting thing about the King's Chamber assembly is that it is totally separate from the core masonry. You know, in a structure, you would like tie things into the core masonry or the core structure for stability and stuff like that. There is a space all around the King's Chamber, separating it from the limestone blocks that comprise the core chamber.
Really?
Right. So you have that particular feature. Tom Danley, who was an acoustic engineer, he did some acoustic testing in 1997, I believe it was at the time he went over there, and he reported that he was doing a sweep at very, very low frequencies, infrasonic, and the frequencies that he picked up were forming an F-sharp chord. So they were musical in nature. The F-sharp is considered to be, by the Hopi Indians, tune their flutes to the F-sharp chord. They consider it to be the voice of Mother Earth. It is the frequency of the earth.
And what was he doing in the King's Chamber to get them to resonate and vibrate like that? To get the blocks to make the sound?
Nothing. No, he wasn't.
He was just in there.
No, when he picked up those frequencies, everything was turned off, and there was no apparent force to cause it to vibrate.
So this was just sort of like the white noise or the background noise?
This was like background frequencies of the room. See, in '95, I took some tests inside the King's Chamber, and I took an RF counter with me. I wanted to check the frequencies, see if there's any EM frequencies coming off the granite, and I wanted all the lights turned off while I was in there. So I paid good money to get in the Great Pyramid, have alone time in it.
Mm-hmm. You rented it out by yourself. Wow.
I was by myself, and
private party.
Private party, yeah. And so anyway, the lights weren't turned off, and I had a recorder with me, and I was recording the whole time I was inside the King's Chamber. And, you know, of course, all this it's not scientific. It's all anecdotal, right? And so when I got a little impatient waiting for the lights to turn off, so I got my flashlight, and I went out to what they call the Great Step at the top of the Grand Gallery, right there. I was standing right there, and I yelled down to the guards outside, "Please turn off the lights." So, and then I scurried back into the chamber before they actually turned the lights off, because I didn't want to get caught in the dark. Mm-hmm. Well, the interesting thing is when I got back to my room later and played back that recording, I had a guitar tuner with me, right?
Yeah.
So, measured frequencies, and it picked up my footsteps on the granite. The granite was ringing at the frequency of 440. It was an A on the musical scale.
An A.
A, yeah, 440. So that was recorded. just my feet striking.
What is the
floor.
significance of it being an A?
It's all about frequency and resonance.
Okay.
And vibration, right? So if you've got energy coming through the pyramid, you're collecting energy in the Grand Gallery, which is this structure right here.
Yes.
Right? Converting vibrations into airborne sound. Those are transmitted into this chamber right here and resonate in this chamber. That is causing all that granite to vibrate.
Okay.
Right.
Okay, so let me see if I got this right. Number A is a subterranean chamber, which is picking up vibrations deep within the earth. That is transmitting vibrations up those shafts. There's two shafts, one that goes like out of the pyramid to the right, and then one that goes up into the Grand Gallery, and then it goes through the Grand Gallery into the King's Chamber.
Yeah, I mean, okay, the prime impulse in the subchamber, which is A. Okay, so
yes.
if you're causing or driving a pulse into the earth and eliciting a response, then that's not designed to necessarily be collected just in the subchamber, right? It's designed to affect the whole area under the Great Pyramid, and for vibrations to flow from the earth throughout the 13 acres of the Great Pyramid.
Okay.
And then flow through to the Grand Gallery and also the King's Chamber. So you're collecting those vibrations throughout. And then converting those vibrations into airborne sound, stimulating electron flow from the granite. And I identified piezoelectric effect as being a principal mechanism for electron flow out of the granite. That changed after I started to do my research on Giza, the Tesla connection.
So what is the specific function of A, the chamber, the subterranean chamber?
In the Giza power plant theory, A is a chamber that contains the means to drive vibrations into the earth.
Okay, so there was there was something inside the chamber underneath the pyramid.
Inside the chamber, yes.
That would vibrate the earth.
Yeah, and also at the same time, probably the pyramid. So it would serve two functions. You'd be sending vibrations not just into the earth, but also into the pyramid itself.
Okay.
So, the subchamber being housing the pulse generator, which there are different proposals on that, how that was accomplished.
Okay.
There's one that's uses hydraulics, hydraulic pulse generator. John Cadman, who is a marine engineer out in Bellingham, Washington, is a supporter of that. And then there is the Tesla version, which is what he called an earthquake machine.
Yes, this was a fascinating part of your book. I had no clue.
Electromechanical device that sends timed pulses into a structure, whether it's a beam on a bridge or an I-beam in a building in New York, which I think there's reports that he did that and almost brought the building down.
Yeah, there was a story. You told the story in your book.
Right.
The story was fascinating. They were in the basement of a huge building in New York, and they turned on the generator, and the building started falling down around them.
For all the time that we have been alive, the US dollar has been the primary currency, but that may not be the case for much longer. China is set to dethrone the dollar, and possibly much sooner than you think. And even the world's biggest economies are already ditching the dollar for the yen. collapsing the U.S. currency, causing unprecedented inflation and crashing markets. And if that wasn't enough, this paves the way for the government to take total control over all of your money with a new digital dollar. Now is the time to take total control of your money and not let your life savings become a casualty of the currency wars. And you can do it using the only precious metal dealer that I trust, American Hartford Gold. They will show you how to protect your savings and retirement accounts by diversifying your wealth portfolio into physical gold and silver. With the finest products, amazing customer service, and a buyback commitment. But you don't have to take my word for it. American Hartford Gold has a 5-star rating from thousands of reviews and an A+ from the Better Business Bureau. American Hartford Gold supports content like this that is committed to bringing you the truth. And if you tell them I sent you, they'll give you up to $5,000 in free silver on your first order. So call them now. Click on the link in the description or call 855-679-1326. That's 855-679-1326 or text CONCRETE, KONCRETE, to 65532. Again, the phone number is 855-679-1326 or text CONCRETE to 65532. Now back to the show.
Right. Well, I don't think anything fell off, but it was threatening to. He had to break the machine. I don't think he
he smashed it with a hammer, right?
Yes. And got the hell out of there, yeah. God. Well, resonance is a really powerful force when you consider it. You know, when you impart energy into a system that is already has a certain amount of energy and is vibrating of a particular frequency, and you catch it at a node, right, a high node. An example would be a pendulum or a swinging ball. Okay, so the swinging ball comes back to you, it reaches the arc height, and then you apply energy right there, then put energy into it and it goes further. And so you can start out very, very with very, very small movements of this. Could be a ton, you know. Maybe you just move it an inch and then it swings back to you and you give it the same amount of force and it moves 2 inches. And then it comes back to you and you step back, and each time you're stepping back, and by the time, you know, you can build up quite a swing on that ball without, you know, going up to it and having to smack it with a hammer and probably break the hammer. But the point is that a small child could create quite an effect just by using resonance. And then, you know, the whole idea of accumulated energy.
What was
What
was the purpose of Tesla's earthquake machine? What was he trying to accomplish with that?
He actually believed and wrote that he thought that you could relieve earthquakes or the severity of earthquakes in the earth. And it was interesting. That was reported. I hadn't read that when I wrote the Giza power plant, because I had made that observation in the Giza power plant that perhaps, you know, with a system for drawing energy out of the earth, one of the effects of that would be the energy that is accumulating in the Earth's plates, where they push together to the point of breaking, or, you know, a rapid release where you have seismic waves moving out.
So going around with this machine and basically creating little mini earthquakes to avoid some big earthquake down the line.
Yes.
Ah, okay.
Yeah.
Okay, interesting.
Yeah, that was one, but that was one of his ideas about the use of his machine.
Okay.
So basically, that was in alignment with what I was thinking.
Okay, and you imagine something like this was down there in the subterranean chamber?
Yeah.
Okay.
Possibly, yeah.
Okay.
I think everything is open to further research and input from other specialists. I mean,
Right.
Obviously, if you're going to start playing around with the planet, you're going to you're going to have to have geophysicists involved, and geologists involved, seismologists involved. You know, you can't just willy-nilly go in there and start putting vibrations into the earth in a great quantity. I don't know.
Yeah, could be dangerous.
I don't know. I mean, you know, it's like you have to be, I think, fully aware of what the outcomes are going to be.
Yes.
The positive and the negative. So, you know, they say, okay, free energy. Is there such a thing as free energy? Well, the energy is there. It's free. You know, just go get it. But it's going to cost you to get it. And then it may cost you to clean up after you get it. You know, it's just like, you know, the nuclear energy or fossil fuel energy and all that. There's always a cost associated with it.
Right.
Right. But the thing with the the electron harvester, and the most significant discovery was made by Friedemann Freund, Dr. Friedemann Freund.
Who is he?
Friedemann Freund, he's a physicist, works at NASA, and he was studying earthquake lights. And his objective was to determine if by monitoring the Earth at these seismic hotspots, if earthquake lights could actually be a early warning system for impending earthquakes. And so he was studying the earthquake lights, different areas around the world.
Okay.
And there was one particular place that it became apparent that there was an earthquake coming, and that was in Italy. It was called the Aquila earthquake. But his discovery is really I think the most important discovery in this century, or in the last century. It's because you have a source of electrons that's directly under our feet. And so what I tried to do in a Giza the Tesla solution was to highlight the idea that, you know, we have been making advances in semiconductor physics, you know, transistors and things of that nature. And we make quantum leaps in understanding and function of devices that control the way electrons behave within a particular device, like a cell phone or a laptop or something like that.
Right.
You know, all of those are amazing advances, right? All those electrons are coming through wires and generated, for the most part, from traditional power plants that are operating principally the same way they have for over 100 years.
Right.
Right? And so they basically boil water, create steam, push turbine blades, rotate generators, and harvest the electrons, and then put it in, you know, transmit it into the grid.
Okay.
Here, it's to recognize that all those electrons that you want are actually under your feet. And there are some areas of the world, in the country, that are more active in terms of earthquake lights than others, and certain areas that are more seismically unstable than others. And so, you know, the question is, should a serious study be funded or followed to investigate whether we can actually access those electrons directly and use them rather than going through the process of extraction of fossil fuels, burning, all the ancillary costs that you have, transportation and stuff like that, pollution. But here you have a battery under your feet. Why could we tap into it and draw that energy out? So what does Dr. Freund do about his theory? He studied the effects. He studied in his laboratory how to generate electron flow in different types of rocks, igneous rocks, like granite.
What is the meaning of igneous rocks? What does that mean?
It means it was formed as magma in the earth, as opposed to sedimentary rocks.
Okay, got it.
Yeah. So the igneous rocks are basically, they contain these peroxide defaults in the minerals, and when they are stressed or pressure is put on them, they will migrate to the surface very rapidly. And he's demonstrated in his lab that he can take a granite block or beam of granite. He put it in a hydraulic press, equipped it with electrodes and a monitor, oscilloscope, put pressure on one end, squeezed it, and electrons flowed from one pole to the other, one end to the other.
Wow.
And he was able to measure it.
That's an explanation for the earthquake lights. This is happening deep inside the earth,
right,
near
exactly,
near these seismic areas where there's fault lines and stuff like that. And when these giant rocks are being crammed together, these electrons are being released and they shoot out through the rock, up through the surface of the earth and into the sky.
Yeah. You want to show a YouTube video?
Yes. Which video should we show?
It's on YouTube.
Okay. What's it called?
It's Friedman Freund, and is TED Talk in Christchurch, New Zealand.
Okay. Friedman Freund, TED Talk in Christchurch, New Zealand. Okay. Is that Dr. Friedman?
That's Dr. Friedman, yeah.
Okay.
He's up in his 80s now. He's a wonderful guy.
Is anybody using this stuff to detect earthquakes now?
No, that's another story altogether. The seismologists are pretty much ignoring it from what I can understand.
And why are they ignoring this?
They prefer the traditional mechanical ways of detecting earthquakes.
That's bizarre that all the mountain ranges surrounding that city were lit up.
Yeah, I know.
By the earthquake lights, right?
Yeah, right.
God. And that's exactly analogous to what would have happened within the pyramids with those vibrations shooting up through that giant pile of rocks that they built in the desert.
Exactly, right.
So the pyramids would have glowed similar.
Yeah, I believe so. There has been an electrical phenomenon detected in the pyramids anyway. I mean, as far as people noticing, like tingling. There was one story about a William Siemens who was climbing the pyramid with a guide, and he detected a ringing in his ear, and a little buzzing on his finger. He fashioned what they call a Leyden jar, which is kind of an accumulator of an electrical charge. He accumulated a charge, and the guide who was kind of bothering him, I think, thought he was practicing witchcraft or whatever. And so he just held out the jar and shocked the guard. The guard went howling. The guide went howling down the side of the pyramid. he was. So that's one of the anecdotal stories that you get. I mean, that's rough, you know.
So how did you and Friedman Freud connect?
So I had, on my 2018 Lost Technologies tour in Egypt, I had some really brilliant minds with me. One of them is Robert Vorter, who is a sound engineer.
Okay.
And there was a geologist there. There was a...
he looks like a sound engineer.
Yeah, he's a front of house sound engineer. Total roadie.
Yeah.
But, super geek.
Yep. He looks like a sound guy, right, Steve?
He's also got a degree in archaeology, by the way.
Oh, does he really? Oh,
Yeah,
wow. Good for him.
That's beside the point. That's the least of his shames. But no, and so I connected with Robert actually when I was writing the Giza power plant, because there was, an aspect to the function of sound within the pyramid, and I had been told about Robert by a gentleman called Stephen Mailer, who was a friend of his at the time. Mm-hmm. So I called him up, and I just asked him a few questions, and he was, yeah, obviously, yeah. Talked about, the harmonics in the Great Pyramid and other pyramids. So in like 2016, we lost contact. We lost touch for quite a while. 2016, I called him, and basically, at that time, I was pondering on writing another book, right? Because a lot had happened since the first book, and people were bugging me. When are you going to write it? When are you going to update the Giza power plant? I was like, maybe never. I don't know, But I really didn't think I had enough material to do a full book. It may have been a new edition of the Giza power plant. And so I went out to visit with him and spent some time with him chatting. We arranged to do the tour in 2018. Eric Wilson, who's an aerospace engineer, he came along. Adrian Lungan, who was a geologist, he came along. There was entrepreneurs. There was other engineers. A lot of technical type people who signed up for the tour, because it was basically just focused on technology. Mm-hmm. There was no other subject matter, Anyway, so while we were there, we were talking about the role that piezoelectricity plays in the production of electron flow in the granite in the King's Chamber, and Adrian Lungan, who said, well, it's reported in some books that it's 55% of the granite is quartz crystal, silicon quartz crystal. In order for the piezoelectric effect to work, the quartz crystal has to be stressed across a particular axis, otherwise it doesn't work. And because of the random orientation of the quartz in the granite, it was seen to not be a very efficient way to generate electricity. Also, as a geologist, Adrian suggested that the amount of quartz in the granite was a lot less than what has been discussed in the past. It was
initially you thought it was like 80 to 90%, and it ended up being...
Initially it was 55%.
Okay.
That's what I wrote in the Giza power plant, based on what I had read in other books.
Okay.
And then he said it may be more like 20%, maybe less than that.
Okay.
So that kind of shut the piezoelectric aspect out of the water.
Okay.
And but I was like, there has to be something else. There has to be something else, right? And so Robert was just doing. He lives in San Jose, California, in the foothills overlooking Silicon Valley, right?
Mm-hmm.
And so he's poking around doing some research on granite and minerals and piezoelectricity, and then he one of his searches he came up with Friedemann Freund and started to look at his stuff.
Okay.
Right. And so then he calls Friedemann up and they arranged to meet, and he went into NASA to meet with him and gave a presentation to the whole NASA group, and it was all about the pyramids and the energetic purpose for the pyramids and the resonance and acoustics of the pyramids, and also the very, very fine manufacturing and machining of the parts that go into it.
And he presented all this stuff in front of a bunch of NASA scientists?
Yeah.
What was the reception he got from them?
They're fascinated. I mean, I talked to them too. They had a group. It's called the Geocosmos Group. It's not a NASA group, but it is a think tank that Friedemann kind of formed to study planetary issues. Phenomenon like earthquake lights and other subjects. But this group is comprised of scientists from all over the world, and so Robert was invited to join that group. And then when I started to get into writing the Giza Power 2, or the Tesla connection, as it finally became known, I actually reached out to Friedemann because I was trying to come to grasp with his research, because if you read his scientific papers, they're heavily involved with. There's a lot of math to it, obviously, and so most of that was above my head. But as you saw in that little video, he was talking to lay people and presenting his theory to lay people in general terms. Right. Even though there were formulas in some of his slides, he was not speaking, above their heads. You know what I mean?
Yes. So is he completely on board with your theory? He supports me, I think, as a person. I've never directly asked him if he supports what I'm doing. There's an appendix in my book that is a transcript of that Christchurch lecture, and so I got permission from him to include it in my book, and he actually went through it and edited it for clarity, and Is that something you think he has to worry about, sort of like backing up your theory, being somebody who's employed by NASA? You think he might be labeled as like a kook or something if he started saying that the pyramid was a power plant?
Yeah, he probably would be. I mean, that is normally people's reaction, and that's like a typical reaction. Mm-hmm. But the thing is with most physicists, and there are other physicists that I've communicated with, is that when politics doesn't enter into their minds when they are studying nature and trying to find answers to particular problems or phenomena. The politics of it is something they have to deal with later. So it's like, they're just going to go ahead and call it like they see it, and then whatever the politics flow from that. I mean, it's just like anybody, Einstein or Oppenheimer or anybody who is breaking new ground and new thinking.
Mm-hmm.
They're eventually gonna be faced with the politics of what their creations become.
Yeah, and there's got to be a lot of politics around something like this. I mean, the implications of this idea is something that could change the future of humanity, the future of the human race. Like, if we could figure out how to power our civilization through using the Earth as a battery and using these rocks to generate electrons and have free energy, I mean,
yeah, or at least
that's not a small idea.
No, it's not a small idea. It's a and it's not, and it doesn't come at a small price tag either. It's like, I mean, there's
compared to what?
Yeah, exactly. That is a brilliant question because it's loaded. It's a loaded question compared to what, you name it, compared to environmental controls, compared to the amount of coal that's in the earth now, the amount that we burn every year, compared to all the maintenance and ancillary activity that surrounds the creation of electricity that we're creating now. Maintenance, oh my God! I mean, you're talking about millions, billions of dollars.
How much you estimated exactly how much it would cost to actually go out there, take all the scientists out to the Great Pyramid, restore it, and actually test it against your theory to see if it works the way you think it works?
No, I did not. No, I wouldn't even dare. Are you kidding me? I mean, yeah, I may have balls, but they're not that big. I don't have the. No, I don't have the gravitas to do something like that. Though in my book,
didn't you estimate it?
No. There was an estimator who his job is to do cost estimations for building power plants. Okay. So he emailed me, and he laid out a quote for what it would cost to create the Great Pyramid, assuming that it would produce like 25 gigawatts of power. And
25 gigawatts.
And he estimated that it would be around $25 billion. But
where would that money come? Where does that cost go to? Like, what specifically does accumulate? What specifically does it take all that money to do?
That's the extraction of the rock,
the
crafting of it, the transportation of it.
That's just the rocks.
But I think, but I really don't know. I mean, when we talk about building a pyramid today using our technology, the technology that we're familiar with, there was an estimate that was made by the director of the Limestone Institute in Indiana. His name was Merle Bucker. And he was asked for an estimate by Richard Noon, who wrote a book called 552,000. Very unfortunate title, but it was a good book. It had a lot of good information.
552,000?
Yeah, it was a doomsday type of book, right? So.
Well, he claimed the world was going to end in the year 2000.
Yeah.
Okay.
Planet alignments, and there'll be a pole shift, and then everybody will fly off.
Pole shift.
So, but I mean, Richard is a wonderful guy. I met him. He's a great guy, and his book is loaded with information. Anyway, so he had included in his book the estimate that he got from Merle Bucker. And Merle Bucker said that the 33 quarries that they have around Bedford, Indiana, they would, if they tripled their output, to quarry and cut enough stone to build the pyramid, a great pyramid, it would take 27 years. just to quarry it and deliver it to the site. That doesn't mean putting it together. They're just delivering the stone. And that's assuming no equipment breakdowns, no union strife, or labor problems or anything like that. Full tripling the output.
Tripling their output
of
would
that,
take
all their
27
quarries.
years. Did they
all
get
their
and
quarries,
what was
27 years.
and that was the cost was what again?
The cost, he didn't put a cost on it. He just said it would be 27 years.
Oh, okay. The $25 billion was to actually complete the pyramid.
Oh, that was an estimate from this estimator in England.
Oh, okay. Got
So, I mean, that is like, you have, ever since people have studied the Great Pyramid and wrote about it, there have been, I don't know, as many people who have opined about building it. You have that many different ideas of how many people it took and what they would do and, and how they would do it. You've got estimates from 10,000 workers to 100,000 workers, from 20 years to 100 years to build it. It's like there's nothing realistic or factual, really hard factual, that you can assert this is correct, until you actually do it and you have some results. So I don't know. I mean, we don't know how the Egyptians did it, and really, right now, we don't know how we would do it because it's armchair theorists are not going to do it. They're not going to build it. You're going to need professionals who get involved and upgrade just about every technology that they're going to use in order to accomplish it. Whether it's a quarry worker who has to, or a quarry company that has to install precision machining that will hold tolerances on blocks of limestone to within 0.010 of an inch instead of 1/4 of an inch, which they may be currently working to. And that's a huge step to take because you have, when you look at craft skills, you go from like quarry working to woodworking to metalworking, where you got machining. Then within metalworking, you got machining, you got tool making, you got gauge making, and all of those particular craft trades work to different tolerances. And the more zeros you put after a decimal point when it comes to the tolerance on a dimension, the more expensive it is to make because it takes longer to make, and the people who are actually creating it are paid more. So you pay more for a tool maker than, say, a machinist. You pay more for a machinist than, say, a carpenter, It's all about how much you invest in a person and how really adaptable they are to working to within those really, really tight tolerances, really small tolerances.
Yeah, because even like the buildings that you see today, even the skyscrapers, if you were to measure the base of those skyscrapers, they're within, like, if I'm correct, I think they're within a 6-inch degree of tolerance. They can be like the square. They could be 6 inches off square, and they can still build according to code, like a skyscraper.
Really? Yeah.
I thought I got that from your book. Maybe not.
No.
Okay, but like you correlate the main thing about this precision is like you don't have to have precision without a function. Like the goal of precision is function, right? Like there's no need to make those things or these blocks, for example, in the Serapeum. What's the point of making them that precise unless they are, it's necessary for a function.
Right, exactly. The only other reason why they would be that precise is that they were employing tools and methods that were capable of no less of precision. So if you consider the quality of products that are made today, you compare your vehicle that's in the parking lot with a vehicle that came out of Detroit in the 70s, and you look at the fit and finish on the body and the other components in the car, you see a big difference in the tolerance and the precision of those pieces. Like, the way a door fits and the gap between the door.
Right.
Right? So the evolution of manufacturing has been to actually eliminate variables in the system or variables in the process that allow for error to exist or to allow for variance to exist.
Okay.
So when you talk about variance, you're talking about anything that varies from a perfect form. So you design a perfect form today in a computer, in the past on a drawing board. This is a perfect form. Make me this. Okay. How much can you tolerate from the person who's making it of variation from that perfect form that you defined?
Right.
Right? Mm-hmm. And that's called a tolerance band.
Okay.
And so that tolerance band has been gradually getting smaller and smaller and smaller over the years. To now, where, like cell phones that they make in their millions, the manufacturing process has been perfected such that every one comes off almost perfect.
But one of the big questions, like even posed in your book, is when it comes to people challenging your idea.
Yeah.
Well, before we talk about that, what sort of response have you gotten from like academia or Egyptologists on your first book, Giza Power Plant? Obviously, your second book's not out yet, but like, what has been the response from people in general?
It is a radical, revolutionary idea that is totally divorced from what the historical records contain, what their theories are. And it's deemed to be fringe pseudoscience. So when it comes to explaining certain features of the Great Pyramid, like the shafts, Egyptologists rely on magic.
Yes, I noticed that in that video you sent. I was watching that you referenced in the book when they had a TV show where they were sending that robot up through the shaft, up to Gatenbrake's door to drill through the shaft. And the narrator was like, why would they end the shaft here? Why would they put a door there? And then it would cut to some scholar saying that it's very obvious if you use logic. The reason for that door is because Khufu's soul needed to open the door to reach the heavens, and you need a door. It can't just be a free-flowing opening to the heavens. There needs to be a door that he has to pass through to get to the heavens. It's just logic.
Yes. Well,
I was like, what?
I don't, I think you may have embellished that a little bit, Daniel.
No, I didn't.
No, maybe
I underplayed that.
You underplayed it.
She literally said, if you use logic, this may not be verbatim, but she did say, if you use logic.
No.
She's talking about souls.
You got the wrong word. It sounds like logic. I mean, it ends in a GIC. It's magic.
Magic.
Logic.
No, but I swear, if you rewatch that, she said logic. She said logically.
No.
She said logically.
Magic. It's magic.
Maybe I didn't hear it right.
You ought to pull up those clips. Do we have them? Oh, never mind.
Yeah.
We'll show them after the break.
Yeah. So, but the point is, these scientists that are being interviewed for this National Geographic video, it's all spiritual and magic. Is there explanations for these things?
Well, yeah. I mean, the explanation for all the shafts, the king, is soul can exit the pyramid and go into the heavens, right? And in that documentary, the narrator asked the question, but what about the Queen's Chamber? Why do they need 4 shafts? And why do they have handles? And, what about this blockage? And then she says, well, Mark Lehner, who is an American Egyptologist, believes that magic could be a part of it. And so then Mark Lehner opines about, well, the Queen's Chamber is just a dummy chamber, and the soul would have no problem passing through limestone.
Right.
And that is what they call a false door. So there's magic involved there. And then Rainer Stadelmann, who is a German Egyptologist, he's in the King's Chamber, and he answers the question about the handles, or what they call, those metal fittings they had. And he says that those are magical instruments that the soul uses to lift the door so that he can pass through. So you got one Egyptologist saying, won't have a problem passing through that limestone, and then another one saying, well, you got to have those magical instruments to lift it. And then I'm thinking, is there a soul? Has that been proven, from a scientific perspective? I mean, that has been a long, perennial question in people's mind, the existence of the soul.
Yeah. Have you ever had a conversation with Zahi Hawass about this?
I have met him a few times. And the first time was in 2001. I was supposed to meet him in 1995, but I didn't. In 2001, I was in Egypt filming with Grizzly Adams for the Pax Television, and he was going to be a presenter also during that time. And so after a day of filming, the field producer and I went up to his office, and he was very cordial, very kind, and which, a very ebullient, charming, charismatic guy. And we asked him, hey, we'd like to visit the Serapeum. We'd also like to go in the Great Pyramid, which was closed at the time. And it had been closed for a while because of cleaning. They were cleaning on the inside, which had kind of surfaced a lot of conspiracy theories about Zahi Hawass digging a tunnel to explore behind Gantenbrink's door before they drilled it. So anyway, so he gave us permission. We got inside the Great Pyramid, and I was very fortunate to capture some photographs of the Grand Gallery ceiling, where I noticed that there were scorch marks, and yeah, the place had definitely been cleaned. Even the ceiling of the Grand Gallery, which is 28 feet high, had been cleaned.
And you've noticed scorch marks?
Scorch marks on the ceiling, yes. Yeah. And basically a pattern that is similar, kind of matched the resonator frames that I had theorized were installed in slots in the Grand Gallery in the Giza power plant.
Before we go into this resonator, when you did you ever have a conversation with Zahi Hawass about the Giza power plant idea or about anything like this, or no?
No.
No. Okay.
No.
Okay. Just curious.
no, I'm not that stupid. I mean, I may be a little zany, but I'm not stupid.
Yeah.
I kind of had his, I had his measure, and I just figured, yeah.
Yeah.
He asked me what I was doing now. There was a meeting before the filming, and we met in the Sheraton Hotel in Cairo. And
do you know if he's aware of your book? Do you know if he's aware of your book?
I believe he is now, because it's becoming a hot property in Egypt. See, the thing is, and this is why I wrote my second book, Lost Technologies of Ancient Egypt, because, in the Western world, there was obviously a huge wall of resistance to changing the history books on Egypt. But I wrote the Lost Technologies to appeal to Egyptian engineers to do their own studies. And guess what?
This tiny end of the wedge.
They did. And so now, wow, just this last week, I got a message from 2 people. The first one was a video that YouTube video on Arabic television of them discussing my next book, The Tesla Connection.
Really?
These are the Tesla Connection, yeah. So they were discussing that.
Who were the people discussing it? Were these like young kids?
No, it was a reporter. It was on national television.
Oh wow!
Yeah, and then just today, I see in my Facebook messages a message from Amada Anwar, who is a principal in the Scan Pyramid mission team.
Yeah.
Had
the Scan Pyramid mission.
Sent me a YouTube video of somebody discussing the pyramid as a power plant, and so everybody in Egypt. I mean, not everybody, obviously, not everybody, but the youth, the young people, in Egypt are turning their back on the old Egyptology model when it comes to the pyramids. And even some Egyptian Egyptologists are now saying, no, the pyramid as a tomb is a dead theory.
Wow.
Yeah, not just one of them, a lot of them.
Really?
Yes. Well, think about it. I mean, think about it. Here you are. You've got some of the most amazing monuments and artifacts that this planet has ever produced within your country, right?
Right.
And you compare those with those produced in other countries, like in Greece, Rome, Europe, anywhere. I think India, it would be a good contender for excellence in manufacturing with their temples. But if you're in Egypt, you're Egyptian, and you're looking at this and you say, this guy is saying that the ancient Egyptians were more advanced than the Greeks, the Romans, or any other culture on the planet. And they will rewrite their own history books, not me.
Ben was telling me that some people have even attacked Graham on this idea. They've gone as far as calling the idea that the Egyptians didn't build the pyramids as a racist idea.
Well, who's saying that? Graham's not saying that.
No, people are attacking Graham, saying that idea is a racist idea. That's what Ben told me, because they said that if you say that the Egyptians didn't build them, you're saying that they weren't smart enough or intelligent enough to actually build these things.
Well, that is
which is the implication, but they're throwing bullshit into it, just trying to label him and slander him and basically discredit the idea by injecting drama. Right?
Yeah, and
for people that don't read into it, people that just read the headlines, the lazy people.
So many things that I don't understand, but my feet in the sand when I'm walking in the sun. Whoa, walking in the sun. One more, 1, 2. Oh, baby, give me one more chance. Won't you please let me back in your heart? Oh, darling, I was blind and let you go. Yeah, but now that I see you, it is I want you back. I want you back. But you didn't have to cut. Make it like it never happened and that we were nothing. I don't even need your love. You treat me like a stranger and I feel so rough. But you didn't have to stop so loud. Have your friends collect your records and then change your number. Like you said, I don't need that though, 'cause now you're just somebody that I used to know. I'll stand in line. I've seen her do this to men 1,000 times. She had a rep for spread. If you seek it, tell her that I'm looking for her. She's so fine. That girl been on my mind, yeah. There's times like these we'll never forget. Staying out to watch the sunset. I'm glad to share this with you, 'cause you set me free. Show me how good my life could be. How did this happen to me? Yeah. What are you waiting for? Wish I could all your secrets. Was I too close to comfort? You're pushing me out when I wanted it all. What was I just